email also, there are a lot of things, 82 now. Last time 0. I always keep my email to be 0. So this is consider that I'm not in the normal mode. So let's proceed. I have now here input and I have output. This is the combination circuit. Whatever input is going to generate my output depending on the input. So no memory. Therefore cannot memorize your previous output. Done. So you need to know about the theory for this thing. What is the differentiation? What is the meaning by combination logic? What is the meaning by sequential logic? What will be trigger for the output? So the output, you can see it has memory element. The output, siapa lagi nak masuk ni? The output depend on the input as well, which is mean N with your previous output from the feedback elements. So you need to remember your output will be depend on your input and the previous output. Okay, done at this part. Mana? Okay. So now you can see here under sequential circuit, you can categorize it to be 3. One is the clock driven. Second is event driven. And third is your pulse driven. Event driven is asynchronous. What is asynchronous? Clock driven is synchronized. What is synchronized? And then pulse driven is the combination of these two. Combinations of synchronized and unsynchronized will trigger the pulse driven. And this clock driven are cyclic and non-cyclic. So you have all. You can read and go through all of these, but just looking at this timing diagram, you have everything. Only that you need to wait. Ada kuih ke? My mom SMS me just now. She want roti canai. Now she want kuih. Ayoyo. Ui. Okay, here. You need to know each of these about the statement because the theory is also will be asked in your final exam for part A. Okay, in your chapter 7, you're going to look into latch and flip-flop. But today I believe we can just cover this one because you need to deeply understand on the latch before you can proceed to your flip-flop. So latch got 3. So this one also you need to remember, latch got 3, flip-flop got 4. This SR latch, the name is SR latch, is not similar to get SR latch. What is the big difference? You got EN. What is EN? Later on you will check. But for now, you need to understand that latches have 3, which is SR latch, get SR latch, get D latch. So it's called as SR, get SR, and get D. Okay, next, here is SR, get SR, and get D. And you can see here, it put here, this is not the name, it's just put a hint here. This is the difference between SR, whereby you're going to have EN, input, which is like a switch. Okay, you can see here, what is S? S is set. What is R? R is reset. What is D? D is for data. And you need to read all of this, okay? What is Latch? Latch is the temporary storage device. Why temporary? Because you remember that you have last time a memory, and then you have what else? It has two stable state, which is bistable, and the level is sensitive or level trigger. Okay, you can read this. So this is the tree of it. Now let's take a look into the first latch we have, which is SR latch. This is the combination circuit that looks inside your latch, and you're going to have two: active high, active low. This one is not new term. Active low, active high. Normally, for your low, you're going to have a bar or a bubble. You still remember this, right? And then this one, I'm going to, okay, I'm going to proceed first. You can see, no need for you to remember the combination circuit inside. But as long as you need this to prove what is the output, is it correct or not? Okay. For this active low, you can also have the NAND looks here, and you can also have the negative O. This one, I think no need for me to explain anymore. This one you already learned on your module 6 or 5. And this is the logic symbol. So active high, it look like this. There is no bubble. Active low, it's got bubble here. This is S, this is R. Before that, the input will be S bar, R bar. Now, we have here active high, and this is the inside this one. But you need to see carefully. This one is R. So this R will be here, and our Q is on top. So please make sure, last time I draw it wrongly. I put this S and R. You're not going to get the similar output. And another one more thing is your active low. This is your active low looks. How it's going to be look like. You can see here. Okay, why and what is the purpose you need to learn all of this? Here is the thing. When you have the input, what is the output? Okay, you have first thing first. You were given with the previous output. This is your previous output. Let me draw. I forgot already. Okay. This is my S. Let's say I have the input of S and R as 0 and 0. And then after that, the previous input of Q is already given. First, we look at this situation. We have 0 here. At the initial point, we call it initial point, the Q is 0. And this 0 will be taking down to below as for this no 1, no 2. Okay, now we have here 0. 0 and 0, we're going to have 1 for our Q bar. And this one will be fit into the R here. It will be 0. You can see this is our new output. This is our previous output. You can see here it is toggled to each other. It's correct. Now I have 0, 0. Previous output is 0. My output now is 0. Correct, right? This is our Q. If you want to put Q bar, it's okay. You can have put Q bar here, which is toggle. Okay, next. Oh lama. Banyak I conteng. So here, you can see you have number 1. Number 2. Scenario 2. You can see. Kenapa I terdelete? Scenario number 2. You have the similar input 0 and 0. But now, your previous Q is 1. 0 and 0. Our previous Q is 1, which is initial value of Q. This one, I'm going to go down to this fit in. 1 and 0, I will get 0 here. Q is 0 and Q bar is 0, and this 0 will be fit in here, and our Q now will be 1. So my Q is 1, my Q bar is 0. This one is supposedly happen because it will toggle to each other, right? So it's correct. What happened? How can we conclude? How we can conclude when we have 0, 0 for our S and R? When it's going to follow our previous input. You can see a previous output. If previous is 0, it's going to be Q also 0. If previous is 1, ya Allah. If previous is 1, it's going to follow, and the output, the new output will be also 1. We call it as no change. So we can conclude for the first time for our SR lectures when we have 0, 0, whatever input for our previous, whatever previous output, it will be no change. So no change means it's follow the previous output. No change. If the previous is 0, it will be remain 0. If previous is 1, it remain 1. So here is the proven for this table. Later on, actually, you just need to remember this table. But of course, before you can go, okay, if 0, 1, latch is reset. If 1, 0, latch is set. I can just ask you to remember this. But instead, you need to understand how come this happened. So here is the explanation why you get this active high to be like this table. Later on for active low, how you get that table. For active low, you try it by yourself. You can fit it in your did simulator if you don't want or lazy to do one by one. But I need to so that you can understand. Okay, next. Our third scenario. Janganlah pada semua. Okay, now our third scenario, we have 0, 0 for S and 1 for R. And our previous output is 0. What will be happen? 0 will be here, 0 and 0, we will get 1 for our Q bar, and we feed it here, we will get 0 for our Q. So this is our Q now. And our Q bar here is 1. Okay, then it's correct. We check another one. If let's say our initial value is 1. This one, the input is similar. If it's 1, what happens? 0 and 1, we will get 0 for our Q bar. And 0 here, we will get 0, 1. 1 will be here is 1. 1 and 0, we will get 1. Become 0. Here will be 0. And then 1 and 0, we will get, correct or not? 1 and 0, we will get 1, 0. Supposedly it will be 0 here. And this part, how come it gets 0? One, putting here 1 and 0, we will get for our no, 1 bar is 0. 0 will be putting here will be 0. 1 and 0, we will get 1, 0. For our Q should be as a 0. You can see here our Q supposedly 0. So here is our Q will be 0. Now you can see here, this is our Q as 0. If you conclude, here, you're going to see if 0, 1, 0, 1, whatever previous output, you're going to have 0 for your Q. It means reset or it's 0. So you can conclude if S is 0, R is 1, you're going to get 0 for your Q, which called as a reset. Now you have the next situation. We have 1, 0, 1 for our S and 0 for our R. And initial value is going to be 0. For this 0, it's going to be fit in here as a 0. 1 and 0, you will get 0 at your Q. And this will be fitting in here, 0 and 0, you will get 1 at your Q. So your Q will be 1 for this scenario. Next, if you have output, previous output as a 1. So here 1 and 1, you will get 0. 0 will be putting here as a 0, 0 and 0, you will get 1. So your Q now is 1. See, this is your Q as a 1. So your Q bar, of course, it will be 0. You can see here, this is 1. What you can conclude, if 1, 0 for S and R, whatever previous output is going to be set or a 1. You can see? So that's why you conclude like this. And lastly, you can try. No, I delete. I delete. Come on, I go back. Ada. Lastly, if it's 1, 1, saya pergi ke sini lah. If it is 1 and 1, if you have 0 here, because you can see you will fit as a 0. 1 and 0, you will get 1. Here will be 0. This will be 0. Here will be 0. 0 and 0 cannot. It's called invalid. You try another one more time. When you have 1 and 1, for the S and R, you have previous output as 1. 1 and 1, you will get 0. 0 will be here. 1 and 1, you will get 0. 1, you will get 0. So still 0 and 0. Supposedly here and here will be toggle to each other. That's why you can conclude that if 1 and 1, your output will be invalid condition. So what you need to remember, when you have active high, you need to have this table. When you have active low, you need to remember this table. What is the difference between active high and active low? For active high, 0, 0 is no change. But for your active low, it is invalid. For your 0, 1, for active low, active high, it's going to be set. It's going to be reset or 0. But for your active low, it's going to be reset, which is it's going to be set, which is 1. For active high 1, 0, you will get a set, which is 1, while for low, it's going to be reset. And lastly, 1, 1 invalid for your active high, and then no change for your low. So just remember these two tables, but in terms of explanation, you can try one by one to prove that you will get these summarizations of your ISR Latch. So where you're going to apply, you can read, this is all the explanation. You will apply in terms of timing diagram. Last time you also, I think, have experience dealing with timing diagram, but now it's look like you're going to have a lot of timing diagram later on. So here is first example. Now you have the SR latch active high. You can see here, this is active high. And first of all, what you need to do, you need to draw the dotted line. Where this dotted line, whatever changes at S and R. In this question, I do believe it's not all, because this question already know the answer. That's why it's just dotted at the following specific things that you need to change. But you can see here, this is the first changes between S. S change from 0 to 1. Okay, then you did the dotted line. Now here you can see there is another changes from 1 to 0. So you need to do the dotted line here. Go until here. There is another, there is no changes for this one as until this part. From 0, you're going to meet to change to 1. So you put the dotted line, and lastly from 1 to 0. This is the dotted line. Done for S. Now you have R. You, of course, this one is similar, the dotted line. already done here. Now from 0, 0, 0, no change, no change, no change, and then suddenly it changed to 1. So you make another dotted line like this. And from 1 is going to change to 0, you make another dotted line here. And from 0 it's going to be 1, another dotted line, and this is another dotted line. And then after that there is no change at all. You have this line to consider. So at each dotted line you need to key in the input value. Here is 0, here is 1. Here is 0, 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 is 1, here is 0. At my R, 0, 0, 0, 1, 0, 1, 0, 0, 0. Okay, done this part. So these two tabs I already done, and do the table for you to refer unless you already like, okay, I already remember everything. For S and R, Q, 0, 0, no change. 0, 1, it will be reset. Reset is 0, okay? 1, 0, it will be set, which is 1, and 1, 1, it will be invalid. So let's take a look what is our output. 0, 0. Starting is initial as low. No change. So you will directly go to the next trigger dotted line you have, which is the changes at the input. You have 1, 0 now. 1, 0 is set to 1. Going to do the set until this dotted line. At this dotted line, you check what is this? 0 and 0. 0 and 0 is no change. No change is similar to whole. So you follow directly until the next dotted line or the next changes of your input. Here is your 0, 1. 0, 1 is reset. Reset means go to 0. So you go until the next dotted line or until the next changes of your input. So now you have 0, 0, which is no change. Until you meet another one is 0, 1 is still 0 or reset. 0, 0, no change. And lastly, another one, another 2. 1, 0 is 1, which is set. And you can see a final is 0, 0, which is no change. Whole or no change. So this is your output. This is the one that you need to draw, or maybe you need to pick which one is the correct output from this one. Okay, any question from these basic things?
So far good.
So far okay, right? Okay, next going to go for another example. This one is from the table. From this timing diagram, you change to the table, whole, set. This one you can change also, no change. And here is another example, but this is for your active low. You can see here, the initial value you're going to give as a low. So you pick as a low at the initial part. And active low, let's draw the table first. 0, 0, 0, 1, 1, 0, 1, 1. This one will be no change. This one will be reset. This one will be set, and this is invalid. Okay, this is table we already looked into. And the first thing I ask you to do what? The dotted line at every changes for your input. So now first thing I have here for S bar. Here there is a changes. Here there is a changes. Why this question didn't put? Because it know the answer. At no change, it didn't put the dotted line. But you as a beginner, of course you don't know, and you don't know the output, you need to do the dotted line there. And I have another changes here. I have another changes at this point. And this one, this also, I have a changes at my S and here, and lastly this one. I done for my S. Now, I tarik. Now, as for my R, here no change until this part. I have changes. At this part also, I have a changes. You can see there is a very small thing changes here. You need to also do. So then you can see what is the difference because our input is different. Luckily for this question, it is no change. But if for others question, sometimes it's got a changes. That's why you need to consider all these dotted line at every single changes for your input. The rest is okay. Now, I already done the dotted line. What I need to do, I need to put the value 10111 0111111 0101. Here is 11101. See, I need to put at this thing because it is different from previous one. Q1 10101111. Done for my step 2. My step 3, I just need to draw. Let me change the color. Okay, now initial is 0. I have the next is my 01. 01 is what? 01 is 1, which is set. Set until my next dotted line. My next dotted line is 1, 1. 1, 1 is what?
Not change.
No change. So here is no change. Good. And you can see here next is 1, 0. It is 0. Or it called as a reset. And after that, we have another one here. It is 1, 1. It is no change. That's why it's directly to go here. And in this question, why it didn't put the dotted line here? Because it know already the answer. And until this dotted, next dotted, you have 0 and 1. 0 and 1, it will be 1. So it will be 1 here. And then 1, 1, no change. 1, 0, reset. 1, 1, no change. 1, 0, reset. 1, 1, no change. This one is 0, 1, 1. 1, 1, no change. 0, 1 is 1, and then no change. So you got the Q output. Of course, if you want to draw the Q bar, you just need to toggle everything. So this is your Q bar. Okay, any question for this? Simple, but you need to remember the table. Okay, let me see another example. This one is the solution. Just now, you have the set, no change, reset, and etc., which is similar. Now, at this example, at this solution, you can see it shows you that you need to do this dotted line also, which is no change for 1 and 1. If let's say dekat sini, if there is something like maybe here will be like this. So you're going to have 0, 1. 0, 1 is 1. So you need to do like this. So that's why you need to check carefully every single changes for your input. You need to draw the dotted line. That is on our SR latch. Is it okay? We're going to move to our next latch, which is on our gate D latch. Just now, for your SR latch, you have two input only. For your SR latch, the difference, you can read all of this, the difference is only at this one. You have EN. What is EN? It is enable, or we can call it enable input. Enable input, and if it is high, then you can consider any changes to your output. But if it's low, there is no changes at all, like off. You're going to off your latch. So you can see here, 1 latch is on, en 0 it is off. Here is your get SR latch. Circuit and symbol. This one is your circuit. This is your symbol. You can try using your dissimulator, or you can manually put the value 0 and 1. And then what is the output for previous Q? Let's say for 0, what you will get a new Q is what. And if let's say supposedly En must be 1. If En is 0, everything will be nothing happen. So here is 1, here is 1. What will you get for Y and Z? And at this part, what will happen if you have Q is, let's say, 0. So you will fit 0 here, 1 and 0. What is the answer for Q bar? And you're going to fit in the value and you get that. You can prove. But after all, you try it to prove everything, but you can finalize it. It is totally similar to your previous SR table. You will get 0, 0, no change. 0, 1, reset. 1, 0, set. And 1, 1 is invalid, although it is a get latch. But when the En is 1. For En is 0, nothing happen, which is no change. Not your wave is stop. Bukannya stop ya, you punya wave tu. It is still continue, but it is no change. Although you said that it is off. Let's see directly what is happening here. This is our get SR latch. And let's draw the table. If it's 0, SRQ, nothing happened, no change. My 1 here, I have 0, 0, 0, 1, 1, 0, 1, 1. Here is no change. Here is reset or 0. Here is set, or it will be 1. And this one is invalid. And assume Q initially as 0. So I put 0 first. First thing, what you need to do, you need to draw the dotted line. I go for my S first. This is my first dotted line I have here. And another dotted line. Another dotted line here. Another dotted line. And this another dotted line. I need to consider all, okay? Step by step. Now, my R, everything is dotted already. And my En. This is considered as input, okay? So I need to draw the dotted line here. Hmm. Okay, I done with my dotted line. Second, what I need to do, I'm going to put the value 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0. And lastly, my end 0, 0, 1, 0, 0, 1, 0, 0. Here is 1, 1, 1. I done. So now my turn to draw my output. First thing I need to consider is my EN. I need to check whether my EN is 0 or 1. So here initial as 0, I need to check the first thing. Of course, this one is nothing happened because no change at the first beginning. En is 0, no change. And then I have another one. En is 0, it is no change. So I'm not going to consider anything at my SNR, although it has the changes in the value, but because my En is 0, there is nothing happen. Then I meet another En, but now my En is 1. So if my En is 1, I'm going to consider my input of SNR. So I need to look into at this side only. At this side, my S as 1, my R as 0. 1 and 0, I'm going to do set. So I'm going to do set. I'm going to do set until my next this only. Until my next dotted line. For next, I meet 0. I meet 0. What is happened? Nothing happened. It's no change. I meet another one. Is 0. Nothing happened. No change. And then I meet my another one here. So for this one, you can see it's going to be 0, 1. 0, 1 is reset, means 0. So from 1, I need to go to my 0 until the next dotted line. Here will be your next one is 1, next one is 0. 0 means no change. 0 means no change. And then suddenly you meet another one here. Another one you need to refer to all here as 1. Going to see 1, 0 as a 1. Until this dotted line first. Here is also another one. What is the input? The input is 0, 1, which is set, reset. And you have another one here. You need to look into your input. You have 1, 0. 1, 0 is set or a 1. So this is your output for Q. If you want to go for Q bar, you can do it. Okay, in terms of the beautiful way, you can see this is a thing. You have here the no change. You're going to change here. You have 1, 0. 1, 0 is set. That's why you set up. And then you meet 0, 0, 0 things. There is no change at all. You can try. So we have another one example. For this example, similar thing. Sama ke tidak? Okay, different. For this one, you need to assume initial as a 0. And yeah, this one is helping much because there is already dotted line for me. I just need to fill in the value. This is get SR. EN 0, nothing change, nothing happen. SRQ 1 1 1 1 0 0 0 1 1 0 1 1. This one will be no change. Reset, set, and invalid. 1 0. Okay, let me put the value. 1 0 0 0 0 1 1 1 1 0 0 1 1 1 1 0 0 0 0. Second, my R 0 1 1 1 1 0 0 0 0 1 1 0 0 0 0 1 1 1 1. And for my N 0 0 1 0 0 1 1 0 0 0 0 0 1 0 1 0 1 1 1. Okay. Now how about our output? We're going to see first thing we have 0, and then we meet another 0, which is no change. No change, no change, and then that suddenly we have 1 here. If we have 1, we need to look into our input. Input now is 0 1. 0 1 will be reset. So it will remain 0. Now you have here 0 0, no change, no change. Then I meet my 1 here. My 1, I'm going to look into my input. Input is 1 0, it is set. So I'm going to set. I meet another 1. I need to look into my input. It is 1 0 again, it is set. And then after that, it is 0, no change, no change, no change, no change, no change until here. Then I meet my 1. My 1, I need to refer to my input. I have 1 0, which is set. I meet for the next input EN is 0, no change. And then I meet 1, I can see my input is 1 0, it's maintained as a set. And another one is 0, which is remain, no change. No change. And then we have 1 here. We look into the input 0 1, it will be set, reset. This one is also 1. We look into the input, we have reset. This one is 1. We need to look into the input, we have reset. So here is my output. From here, you can play around with the table later on, which is, this one is similar. I guess, yes, this one is similar things. Any question for this part? One, you can just fill in the value in the things that I mentioned. And basically, you will get a similar whatever input we have. Okay, we're going to move to our get latch. Before that, everything okay or not? Okay, doctor. Okay, thank you for
Okay
response.
sikit.
Okay sikit. Kalau I laju sangat, you bagi tahu sebab I tak tahu in term of my speed. Laju ke, slow ke. So you just stop me whenever you think that laju sangat ni. So here, let me proceed with our get the latch. For my get the latch here, I have the different only, just now we have SR, SR, SR. We have 2 input to look into. But now we have only 1 input. We have only 1 input. what is the things that you need to consider just now if you look into your SR? Okay, your SR in the beginning, let me go for the SR first. Okay, this is your SR. And then if you want to add another for your get lash, you're going to add another things here. You can see this example. Mana get here, you can see this is your get this is your SR lash. When you have another one here, all together will be your get SR. For if you have another one is not get, I do believe that is not get there, you're going to have D lash. So here is the D lash here. This is your SR. This is your get SR. This is your altogether D lash. SR, get SR, and altogether your D lash. Okay, but I don't think that you need to remember all the circuit inside. You just need to understand how basically it's happened and how you can derive to get this concrete table. So for get the latch, it's much easier if you compare to SR lash, get SR lash, because you have only one output. You only have one input to consider. So of course, to the power of one, you have uh two two what possibilities for the output. For just now you have to input, so you have four things, right? The four tables, 00, 01, 10, 11. Now of course you have D only. That's why you have only D0 or either a 1. Of course your EN, you have another EN. If it is 0, nothing happen, no change for your Q. But for your EN as a 1, you can see you have only 0 or 1. And what is the output for your Q? Your Q will follow exactly your input. Here is the thing. So that's why I said it's very easy. You can memorize the table easily, but in terms of implementation, that is the things when you need to come up with this timing diagram. Okay, all the thing here is just for your theory, for you about the explanation. If your condition of D0, what will happen? For D1, what is happen? You can try to derive by yourself, put the value in, the value of 0 here for D. Of course, your EN should be 1 to open, to on. Now your Q need to be have the previous output. Let's say you play around with 0 first. So let's check what is the output for Q and Q bar. And of course, you're going to have the similar things. Okay, now let's take a look at this example. For this example, you have here, first thing first, what you need to do, you need to do the dotted line for the D changes. Here, sorry lah, I don't have pembaris here. Don't have ruler. And here, again, in this question, it just shows use at the specific dotted because it knows the answer. But for us, we still don't know about the answer. That's why we need to consider all changes for our input. Now we're done with our D. For our next input is EN. So here is another dotted for EN. Aduh, agak serabut lah bila I lukis ni. Okay, this one is done. So first thing is going to be low, but before that you need to put the value so it's easy for you later on to check. 0 1 1 1 0 0 0 1 1 1 0 1 0 1 0 1 0. For your N, 0 0 1 0 0 1 0 0 1 0 0 0 0 1 1 1 1 1. Every dotted you need to put. Now my initial is low. What color I want to? Okay lah, merah pun boleh. Start with 0. My EN. EN 0 1 1 D. Doesn't care 0 or 1. Our output will be no change. For 0 and 1, it will be 0 and 1 also for our Q. This is the table just now that you need to remember. Okay, for 0, nothing changed. I meet my 1 now. So my 1 here, I need to check my D. So my D is 1. So that's why I'm going to change to 1. Next one, I meet another one is a 0. So I continue, no change. I meet 0, no change. I meet 1. My 1 here, I need to check my input. My input is 0. It's going to be 0 also. Until this part, I meet 0, no change. I meet 0, no change. I meet 1 now. I need to stop. 1, I need to check my input. My D is 1, so I will be 1. Here is 0, no change. Here is 0, no change, no change, no change until I meet my 1. 1, I will look up here. It is 0. This one is 0, so will be 0. 1 will be 1. 1 will be, look here is a 0. 1 look up here, it will be 1. 1 look up here, it will be 0. So here is my output using this table. It's much more easier if you compare to the S and R because you have only this state to remember. How to apply only you need to figure out. If you don't know about the dotted line, maybe you just consider okay, one here, one here, one here, but then you don't know basically what is happening. Although you know the table, although you can memorize, but of course sometimes your answer will be wrong. Okay, so that's why you need to do carefully first the dotted line, carefully do it, and then second you fill in all the value 0101 so you can easily refer to the table later on. Then the third you draw. To draw, you need to first check your EN. After EN, then you can consider your input. Okay, any question until up here? Okay, if no question, let we do okay. Let me do some recap first on your flip-flop. why you need to have a full understanding on your latch, because flip flop, although I think it's much more easier, but there is several steps you need to do. Consider if you compare to your latch. Uh, what you're going to see is SR, H trigger D, JK flip flop, and the toggle T. Slightly different with the latch, you're going to have clock. This is positive, this is negative. And then you're going to compare, tomorrow I'm going to show you how you're going to compare with latch and flip-flop. Although you can see here, your input is similar, totally similar, but your output is totally different if it is latch and also flip-flop. Next, not only that, for your flip flop, you're going to meet with the things called as free and clear. Mana tak sampai lagi ni? Terlepas. You're going to meet with free and clear. And now you're going to learn on the priority table. Just now you have only these two. Just now is EN. So here, if you have free and clear, you're going to prioritize these. After that, just you look into the clock, and after you look into your clock, then you can look into your input. It is about synchronized and unsynchronized thing. Tomorrow we look, okay? We have another 30 minutes. I'm going to explain about your project. Okay, shall I proceed? So you're going to do a group project. Who's your team member? Your team member will be the similar team that I assigned for your lab group. For your lab group, you're going to use a similar one. And then you're going to do it together. But the due date, I'm still waiting actually for the Senate to confirm whether we're going to extend our 1 week SEM or not. Because last time there is several argue about this, because actually we already have the final exam date, right? But after we extend another 1 week, is it going to be similar or not? So yeah, about the due date, don't worry. I'm going to consider about that. And this project is totally similar to all 10 sections for this semester. So all will be using similar, which we prepared by Dr. Fuad. I think they missed wrong this one. And also Dr. Ismail. For this one, you're going to have part A, part B, and part C. Part A, part B, and part C. Part A, you can start now. Okay, part A, you can start now because you already done the combination logic. For part B and part B and integration, of course, you need to learn for your module 7, module 8. Later on, you're going to meet the counter and the clock at your flip-flop and etc. So that's why this one you can do it later, but you cannot wait until finish all the module. You need to start now. What you need to do is you discuss with your team member and search at Google what scenario that you want to do. There is several scenario that you can pick, like leave, if you look on your module 8A in your ebooks, you're going to see there is several example also about your parking, about your bomb, uh, apa lagi lift, I think so. So there is several example. So in this, you need to find a real case, but you are the one to justify every single thing about the input. What is the input? If you still remember in your module 5 about the problem statement, so that is the thing. You were given with the scenario. You need to come out with the solution. Input what, output what. But now you need to justify by yourself what is the input, what is the process, what is the output. So here is much more clear for if let's say you were given with this example. You were given with the leaf scenario. You can see you may choose any system you want to design the controller and study how does the system work. Of course, it's although you are the one who decide, but you need to relate it in a real situation. Let's say for leaf, you are the one to justify how many level you have. Janganlah you buat satu dengan dua level saja. Terlalu senang. So in this example, you can see it's go for up 8 level. So you need to mention in your report, these leaf are for building at level. So let's say kalau you go in for your leaf kan, if you go for your leaf, there is a button open, macam mana? This close and then open, and then there is ground floor 1, 2, 3, 4, 5, whatever number. Let's say you are the one who decide. 1, it will be 0, 0, 0. 2, it will be 0, 0, 1, let's say. 3, it will be 0, 0, 1, 0. So this thing you decide. Okay. And then you will see the flow. Okay, you already learned on the comparator. Let's say if you still remember, you have more, you have less, you have equal. Let's say now your leaf are moving up. Moving up. It will see where is a current level. Let's say you're going to go to level 7. So your comparator will be doing what? It's going to compare. You want to go to 7. Now your level is level 2. If level 2, of course, you're going to compare 7 and 2, 2 and 7. Is it more or less than 7? Of course, it's going to be less. So if less, you're going to justify in your program. If left, it's going to move up. And if let's say you are at level 8 now, but you want to go to level 7, so you can see it's more than 7. If it's more than 7, using your comparator, what your output will be? Your output will be leaf down. So all the scenario, you need to relate with your comparator, with your marks or D-marks, whatever there. And in this example, you can see it used the comparator for the leaf. Switch, this switch is the key input. Let's say you put 1, it will be 0, 0, 0. Because you have at level, that's why you can see it use 3 bit. If you have like 16 level, of course you're going to have 4 bit switches. If you have like 4 level building, you can have enough 2 bit switches. So all of these you need to justify and conduct and configure it by yourself. So for example, At level, you have 3-bit switchers. The one that you press after user press the button at your leaf, then you will see justify is going to be 001. So your switch will be read 001. What will happen? You're going to feed it into your 3-bit comparator. You're going to compare what level, and then of course, whenever you move from one level to another, it's going to be count, isn't it? Level 1, level 2, level 3. And if you need, this one is extra accessory. If you need the display, you can put the display also. So if let's say currently you want to go to 7, so it's going to pop up the 7. This one is display, I think. Let's say now you are at level 2 and you want to go to level 7. So all the thing you need to discuss with your team member, what scenario and what is the thing that will trigger whether the door is closed, when the door will be closed. After they key in the button of like this, or this one will be door open. So all the button you will assign, and then lift goes up to destination when the comparator compare the level. Maybe lift stop if it is equal. The comparator is equal, then it's going to stop. This one is accessory if you want to play around with sound notification. Arrive to level 7. Then you put the sound. Take in-card hotel. This one you also can justify. If let's say your room number is 701, so instead you cannot go more than 7. Ataupun if you just key in the hotel 701, the card already have, without pressing any button, it will go to the level. This one is key in. So it's depend on you. You are the one who justify this scenario. And this lift down also, because we have a lot of lift. Sometimes lift like this, especially for hotel. Sometimes they use the card. Sometimes they didn't use the card. Or maybe you just use the lift for hospital. There is no card, of course. So it's everything manually key in the level. Same goes to the lift goes down. You are the one to decide. Okay. So there is a lot of thing. I'm going to upload this slide to your e-learning. You can start discuss with your friend. What is needed? You need to have a report here. This is the format. You need a title page, table, content, report, of course, about your scenario, about your circuit, and references. This is the thing that you need to do now. Meet your team member, discuss, go for Google. Uh, what kind of scenario that you want to pick. So, of course, there is several similar scenario. Let's say lift. This similar scenario, similar scenario. All this reference A, reference B, reference C, you need to list this reference in your report. So you just Google. And also appendixes, if let's say you want to put the extra figure when you use the deed simulator. Don't use other than deeds. Jangan guna your words or your paints, whatever other tools. You need to only use deeds for drawing your circuit. And lastly, you need to do a video demo to run your circuit and etc. And of course, your presentation. Later on, we will discuss some more, but I want you to start now before you go for your Module 7, Module 8, which is your Part B, Sequential Logic. Start with finding the scenario, finding what you want to have for the scenario, and then try to figure out what is the combination logic that you can use. Or maybe later on you need to having extra sequential logic, then you can combine. Any question? Masih tak dapat lagi kuih mak saya ni. Any question? Tak ada masalah. Okay. Okay, sekarang tak ada soalan. So, I think only that. Tomorrow we're going to meet and continue our flip-flop. Before you go for flip-flop, as I mentioned, jangan lost. So you ada extra like 15 minutes, go through the slide, go through your notes related to your flip-flop, then it's easier for you to understand. I takut I laju sangat, you cannot catch up, but you can always stop me, okay? For those who just joined, please scan your QR code, and for the rest, you can dismiss. I'm going to upload in your e-learning the slide for your project. Okay? Thank you and stay safe. Bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you,
Thank
Doctor.
you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Okay. Okay, bye-bye.